Good morning, students. This is the first part of our chapter Light, Reflection, and Refraction of CBC Class 10 Physics. In this chapter, we are discussing about some phenomena related to light. Dear students, all of you take your physics notes and pen. I will give some questions in between this class. Please write these questions in your physics note. Now, we are going to our chapter. All of us are familiar with light. At night, when we switch on a bulb, everything in the room becomes visible. Nothing is seen when the bulb is off. During the day, we are able to see the world around us due to the light from sun. Therefore, light as a form of energy which produces in us the sensation of sight. Students, I repeat, light as a form of energy which produces in us the sensation of sight. There are several phenomena related to light, like reflection, refraction, polarization, interference, and diffraction. We will study the topics diffraction, interference, polarization in the higher classes. In this chapter, we are dealing with two topics. First one, reflection and refraction. Before we start our reflection, we have to understand two more terms. First term, medium. Students, please take your note and write the first question. What is medium? A medium is a substance through which the light propagates or tries to do so. Once again, medium is a substance through which light propagates or tries to do so. I think the definition is very clear. And the medium is classified into three types. First one, transparent. Second one, translucent. And third one, opaque. So what is transparent medium? A transparent medium is a medium in which the light propagates easily. For example, air, water, glass. In these media, the light can pass very easily. Such mediums are called transparent medium. And the second type is translucent. It is a medium through which the light propagates partially. For example, paper. Paper is not able to pass the whole light incident on it. It passes only few of them. Such mediums are called translucent. And the third type of medium is opaque. Opaque medium means it's not able to pass any light through them, which cannot propagate any light, through which the light cannot propagate. For example, wood, metals, they are not able to propagate or they are not able to pass the light through them. Such mediums are called opaque medium. Okay, once again, medium are classified into three types: transparent, translucent, opaque. Students, what is transparent medium? It's a medium through which the light propagates easily. And what about the translucent? It's medium through which the light propagates partially. And opaque medium is the medium through which the light cannot propagate. Okay, clear? Now, the second term. What is ray? Ray is a light. Ray of light is the straight line path along which the light travels. Here, like this. This is a ray. This is another ray. It's a ray of light is the straight line path along which the light travels, and it is represented by a arrowhead straight line like this or like this. Okay, now we are moving to our topics. First topic is reflection and second topic is refraction. In this video we will discuss the term reflection of light. We will discuss the refraction of light after some classes. In this we are discussing about the term reflection. We are already familiar with the term reflection. In the 9th class we are studied about the reflection of sound, and in the lower class we are already studied the reflection of light. But once again I will repeat what is reflection of light. Dear students, do you know what is reflection of light? Reflection of light is the phenomenon of bouncing back of light in the same medium on striking the surface of any object. Let us consider. This is medium A and this is medium B. The light from the medium A travel and strike on that object, and it will move back to the same medium A. This phenomena of moving back or bouncing back of the light into the same medium is called reflection of light. And there are two types of reflection. First one, regular reflection, and the second one, irregular reflection. So what is the difference between this regular reflection and irregular reflection? Look at these two figures. This figure represents the regular reflection and this figure represents irregular reflection. In this regular reflection, the set of incident rays is reflected like this, is reflected only in one particular direction. But in this case, this incident light is reflected in different directions. Such reflections are called diffuse reflection or irregular reflection, and it is usually termed as scattering of light, and it is usually take place in rough surface. And this type of reflection is taken from the smooth surface, and this the reflected rays travels only in one particular direction is called the regular reflection. Students, once again, the regular reflection, the incident set of parallel rays are moves in only one direction. It is called a regular reflection. And another type of reflection is from the reflection from the rough surface is called irregular reflection, and in reflected rays are reflected in different direction. Now we are come across two terms. First term, incident rays, reflected rays. What are they? So now we are moving to the terms related to reflection of light. First one, incident light. What is incident light? Students, do you know what is incident light? Incident light is a ray of light that falls on the reflecting surface. This one. This ray of light is incident ray. This is the incident ray. It is falls on this medium. And this arrow represents the direction. And this is our reflected ray. So what is reflected ray? A reflected ray is a ray of light is sent back by the reflecting surface. Here, this is our reflected ray. Students, is it clear? Okay, then the next term is normal. What is a normal? Normal is a line at right angle to the reflecting surface to the point of incidence. Here, this red line is the perpendicular line to the surface. This perpendicular line is called the normal. And the next term is angle of incidence. What is the angle of incidence? Angle of incidence is the angle made by the incident ray and the normal. Look at the figure. In this case, this angle, the angle between incident ray and the normal is called incident angle or angle of incidence. Okay, now the next term is angle of reflection. What is angle of reflection? Angle of reflection means it's the angle between reflected ray and the normal. This angle between reflected ray and normal is called angle of reflection or reflected angle. Clear? Now we are moving to the next topic. Our next topic is laws of reflection of light. We have to study two laws. First, this angle of incidence and this angle of reflection are equal. That is our first law. Students, please note, this is first law of reflection. This angle of incidence and this angle of reflection are equal. That means if this is 30 degree, this is also 30 degree. If this is 60 degree, this is also 60 degree. If this is 90 degree, this is also 90 degree. Okay, then the second law, the incident ray, the reflected ray and the normal are lying on the same plane. Okay, these are our two laws of reflection. Once again I repeat the laws of reflection. First law, the angle of incidence is usually represented by the letter I, and the angle of reflection is usually represented by the letter R, equally are equal. That means we can write according to the first law of reflection. Angle of incidence I is equal to angle of reflection. That is our first law. Okay, is it clear? Then second law, the incident ray, normal and reflected ray are lying on the same plane. Okay, these are the two laws of reflection. Now we have to study two more terms. It is virtual image and real image. So what is a virtual image? Virtual image is an image which cannot be obtained on a screen. Such images are called virtual image. The virtual images are always erect. Erect means if this is your object, you will get image like this. This image is called erect image. And if this is your object and if your image, you will get the image like this. It is called inverted image. A virtual image is always erect. Then comes the real image. Real image is the image that is formed, or we can obtain that image on screen. Such images are called real image, and the real images are always inverted. We will say like that: real and inverted, virtual and erect. If the image is virtual, it is erect. If the image is real, it is inverted. Okay, now we are moving to our next topic. Our next topic is types of mirrors. We have two types of mirrors, mainly plane mirrors and spherical mirrors. Plane mirrors means if their reflecting surfaces are plane, such type of mirrors are called plane mirrors. And now we are just going through the what are the properties of images formed by a plane mirror? Look at this. This is an object and this is a plane mirror, and it forms image of this object here. In this case, this distance and this distance must be same. So if this is 30 centimeter, this is also 30 centimeter. And the properties of the images of the plane mirror is, first one, it is virtual. That means it cannot obtain on screen and it should be erect. Look at this figure, you will get an image like this of this candle. Okay, and the second one, and the size of the object and the size of the image must be same. Then third one, it is same distance from the, it has the same distance. If this distance 30 centimeter, this distance is also say 30 centimeter, and the image is obtained just behind the mirror. And the fourth property is, it is laterally inverted. Laterally inverted means sideways inversion. And the fifth property is, the magnification of plane mirror is +1. We will discuss the topic magnification after this class. So just note down, the magnification of the plane mirror is +1. Once again, I repeat, the properties of the images of a plane mirror are virtual and erect. First one, virtual and erect. Second one, same size of the object, and the image is formed just behind the mirror. Here this is your image and this is your object, and the image distance and the object distance must be same, and it is laterally inverted. And the fifth property, the magnification is +. Students, please write the next question. What are the properties of the image formed by a plane mirror? You have to write these 5 points. Okay, now we are moving to next type of mirrors. Then our next type of mirror is spherical mirrors. What are spherical mirrors? The spherical mirrors are the mirrors in which the reflecting surface is curved inwards or outwards. In fact, a spherical mirror is that mirror whose reflecting surface is a part of hollow sphere of glass. One side of the mirror is well polished and reflecting, this one, this side, and the other side of the mirror is opaque, this side. This means this side is opaque, not able to pass the light, and it is oftenly painted red or green. So students, please note this one. A mirror has two surfaces. First one, two sides. First side, a polished side or the reflecting side, this one, and the second one, a opaque side, this one. It is usually painted with red or green color. Okay, and we have, so it is clear, spherical mirrors. We have two types of spherical mirrors. They are concave mirrors and convex mirrors. What is the difference between this concave mirror and convex mirror? Just look at these two figures. In this case, this reflecting surface is bulged inwards. Such type of mirrors in which the reflecting surface bulged inwards or curved inwards is called a concave mirror. And look at this figure. In this case, this is your reflecting surface, and this reflecting surface is curved outwards. Such type of mirrors is usually named as convex mirrors. Students, once again, if the reflecting surface is curved inwards, it is called a concave mirror, and if the reflecting surface is curved outwards, it is called a convex mirror. Students, please write the next question. Represent concave and convex mirror. And answer is, this is your concave mirror and this is your convex mirror. Okay, now we are moving to some terms related to our mirrors. First term is center of curvature. I already told you that this is our convex mirror. The reflecting surface is bulged outwards. If you complete it, you will get a sphere like this. Likewise, our concave mirror also, the reflecting surface is bulged inwards, and if you complete it, we will get a sphere. That's why they are called the spherical mirrors, and they are the part of a sphere. Hence these mirrors are called the spherical mirrors. We have to study some important terms related to spherical mirrors. First one, center of curvature. Next, focus. Third one, principal axis. Fourth one, pole. Next, focal length and radius of curvature. Now we are moving to these terms one by one. First term is center of curvature. What is center of curvature? Look at this figure. In this figure, this point C represents the center of curvature. So what is center of curvature? Center of curvature of a spherical mirror is the center of the hollow sphere of glass of which the spherical mirror is a part. Here, this is our spherical convex mirror, and we complete it, we will get a sphere, and the center of the sphere is called the center of curvature. Okay, clear? And it is usually represented by the letter C. Likewise, in concave mirror, this is our concave mirror, and this is a part of this sphere, and this sphere has the center, and this center is called the center of curvature. Okay, clear? Now we are moving to the next term. Our next term is radius of curvature. In this figure, this CP, this distance CP from P to C, here also C to P is called the radius of curvature. So what is the radius of curvature? Radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which the spherical mirror is a part. Once again, the radius of curvature of a spherical mirror is the radius. All of you are familiar with the term radius, this distance. The radius of the hollow sphere of a glass is of which the spherical mirror is a part. In figure, this distance CP is the radius of curvature, and it is usually represented by the letter capital R. The next term is pole. What is pole? And pole is represented by the letter P, and the pole is the center of our mirror. It's called the spherical mirror. The center of the mirror is called a pole, and it is usually represented by the letter P here. This is our pole. Okay. Then the next term is principal axis. Principal axis is the line passing through pole and center of curvature. In this figure, this XY represents this principle of axis. Once again, students, principal axis. Principal axis is the line passing through pole and center of curvature. Okay, and in this figure, it is represented by the line XY. Okay, and the next. Okay, once again, I repeat the four terms. First one, pole. What is pole? Please, students, please take your physics note and write the questions. Define the following terms. First one, center of curvature. Second one, radius of curvature. Third one, pole. Fourth one, principal axis. Students, please write in your notebooks. Define the following terms. Question is, define the following terms. First one, center of curvature. Second one, radius of curvature. And third one, pole. And the fourth one, principal axis. Okay. So, what is center of curvature? We all already studied this mirror. If it is concave or convex, it is in a part of a sphere, and it has a center. That center is called center of curvature, and it is usually represented by the letter C. And write the definition. The center of curvature of a spherical mirror is the center of the hollow sphere of glass of which the spherical mirror is a part. Next term, pole. This is your pole. Pole of a spherical mirror is the center of the mirror. It's the center of the mirror. It is usually represented by the letter P. Write the definition. The pole of a spherical mirror is the center of the mirror. Next one, radius of curvature. In this figure, this PC represents the radius of curvature. And write the definition. The radius of curvature of a spherical mirror is the radius of the hollow sphere of glass which the spherical mirror is a part. Next, principal axis. The principal axis of a spherical mirror is the straight line passing through center of curvature and pole, and this is your principal axis. Okay, write down in your physics note. Okay, now we are moving to next term. The next term is principal focus. The definition for the principal focus of a concave mirror and convex mirror are different. First, we are defining what is the focus of a concave mirror. After the definition, I will give the explanation. Principal focus. Principal focus of a concave mirror is a point on the principal axis of the mirror at which the rays of light incident on the mirror in a direction parallel to the principal axis actually meet after reflection from the mirror. Once again, the principal focus of a concave mirror is a point on the principal axis of the mirror at which the rays of light incident on the mirror in a direction parallel to the principal axis actually meet after reflection from the figure. In the figure, this point F represents focus. So what is focus? This is principal axis. These are the parallel incident rays to the principal axis, and this incident ray after reflection from the mirror meet at a point. Look at this figure. This is a parallel incident ray after reflection meet at a point. This point is called principal focus, and it is usually represented by the letter F. Is it clear? Once again, the parallel incident ray parallel to the principal axis, the incident ray which is parallel to principal axis after reflection meet at a point. This point is called focus. Usually a concave mirror is called a converging mirror because these rays are converging here. These parallel rays are meeting here. Hence it is called a converging mirror. And the principal focus of a concave mirror is a real point, and it always lies in front of the concave mirror. Okay, clear? It lies in front of the mirror. Is it clear? Once again, what is principal focus of a concave mirror? Principal focus of a concave mirror is the point on the principal axis. Okay? What is the property of this point? The parallel incident ray after reflection meet at point in the principal axis. That point is called here. Once again, this ray parallel to the principal axis after reflection meet at this point on this principal axis, and this point is called the focus of concave mirror. Okay, clear? And it is represented by the letter capital F. And the distance from this F to P, here P is not marked, this is the P, the center of mirror, and this distance PF is called focal length. Okay, the distance PF, this distance from F to P is called focal length. The F to P is called focal length. Okay, now we are moving to the definition of focus of a convex mirror. Now first listen the definition, and after that I will give the explanation. The principal focus of a convex mirror is a point on the principal axis of the mirror, from which the rays of light incident on the mirror in a direction parallel to the principal axis appear to diverge after reflection from the mirror. Okay, once again the definition. The principal focus of a convex mirror is a point on the principal axis from which the rays of incident on the mirror in a direction parallel to principal axis appear to diverge after reflection from the mirror. Look at this figure. Here, this is your convex mirror, bulged outwards. And this is your incident ray. In the case of convex mirror, when the light is incident, after reflection, it will diverge like this. Here, it is diverged like this. And this diverged light will appear to be come from this point. This point is called focus of convex mirror. Once again, listen. This is your incident ray. Once again, this take the example of this ray. This ray is coming, and after the reflection, it will diverge like this, and it will appear to come from this point. This point is called the focus of convex mirror. And this point is also represented by the letter F, and it is a virtual point, and it is always lies behind the convex mirror. Okay, once again, it lies behind the mirror, but in the case of concave mirror, it lies in front of the reflecting surface, but in the case of convex mirror, it lies behind the reflecting surface. Okay, so what is, and this distance from F to P is also called the focal length. Now once again, do you understood what is the terms? Principal focus of concave mirror. In the case of concave mirror, the rays incident parallel to the principal axis meet at a point. This is the another ray. This is one example. This coming after reflection, it will meet at this point. This point is called the focus. Okay, this is another one. There are these rays coming, and after reflection, it move like this, and it meet here, and this is focus. And usually a concave mirror is called a converging mirror. But in the case of convex mirror, the light is diverged. Here it is incident, after that it is diverged, and it is appeared to be come from this point. All the rays like this, it is incident and it is diverged. The case of convex mirror, all the lights are diverged, hence it is called a diverging mirror, and all the diverged rays are appear to be come from this point, and this point is called a focus of convex mirror. Is it clear? Okay, and it always lies behind the convex mirror. Okay, and this distance between F to P is called a focal length. Students, please write the next question. Represent the principal focus of a concave mirror and convex mirror, and draw these two figures. This is your answers. This is the focus of concave mirror, and this is the focus of convex mirror. And the next question, define focal length. What is focal length? Focal length is the distance from pole to f, pole to focus, is called focal length, and this focal length is represented by letter small letter f. Okay, now we have one more relation. We have to study one more relation. Here there is a relation between radius of curvature and focal length. The radius of curvature and the focal length is represented by the relation r is equal to 2f. This is the relation between radius of curvature and focal length. R is equal to 2f. That means if PF is 5 centimeter, PC is 10 centimeter. Our PC is the radius of curvature and PF is the focal length. If PF is 5 centimeter, PC is 10 centimeter because R is equal to 2f. And when you are drawing this figure, you have to mark this PF and CF must be same. That means if PF is 5 centimeter, CF is also 5 centimeter. If PF is 10 centimeter, CF is also 10 centimeter, because we have a relation R is equal to TF. It is both same in concave and convex mirrors. So next, write the next question. Write the relation between radius of curvature and focal length. So the relation is, answer is R is equal to 2f. Okay, this is your first part, and I will upload the next part on the next day. You have to write all the questions that I discussed in this section. Okay, thank you.